First off, Happy New Year for 2019. Yes, we have progressed yet another year. Greetings, the Astro 30 here yet again, and I want to retouch on a subject I did last year now. It was only yesterday that it was last year, but was with a Discreet Op Amp, or Discrete Operational Amplifier. And the tests I did, I had it built up on breadboard, and the results were disappointing for this circuit. Mainly because I'd inadvertently shorted the output and destroyed one of these output devices, so that's the reason why I was getting skewed results. So I've reprinted the schematic off of the ESP website, which I'll link in the description below, to this whole entire project, so you can look at it yourself. Now, I've tested the circuit, it does work, yes, but of course I shorted one of these output devices. I think it was the 559 that I found was, when I put it through my component tester, it took a long time to test, and then it said please insert a 100 nanofarad capacitor to do the calibration of the unit, which means that the transistor was completely and utterly stuffed. So, with that in mind, I have now made a PCB for this, and it's fairly simple. It still follows the same schematic. There's no modifications in component values. I believe I have a 2K7, which is the degeneration resistor here in the long tail pair. If not, I can use 2K2. But what I'm going to do is going to make this PCB up. I'm going to mount all the components, then I'm going to do an open loop gain test and a closed loop gain test, as I did in the previous video, and we'll just have a look at what the results are. Now, this will be compared to an NE5532 operational amplifier, but just one thing, remember that this does not have any output short circuit protection whatsoever. So as soon as you short the output, you kill one of these transistors, and then the thing never works again. But after I've done that, I'll hook it up as a simple preamplifier maybe, and yeah, we'll see what it sounds like as a preamplifier. Why not? And this is my PCB printout. We can see it's pretty small as compared to this pen. So I need to find a piece of pre-synthesized board to make this on. And as for these input and output connections, I've got some PCB pins lying around somewhere, so I'll just use them. So anyway, let's get to making the circuit board. This is why I keep scrap bits of PCB that I've cut out other boards for. This is what was left over out of a complete sheet, and I've just cut it down like that. Because this circuit fits just nicely on one of these boards. There is a nick here I've got to be careful of, but yeah, the pattern will fit just neatly within that piece of material there, or even on that one. So I'm going to probably keep this separate, and I'm going to use this bit, just use the whole thing up. There it is exposed there. Turned out reasonably well. A couple of little blemishes I had to fix up with an etching resist pen. So now we're ready for the next stage, which is etching it. We'll check back shortly when we got some progress. Well, I've got some progress. It is etching, even though I've been at it for 20 minutes. It seems like an awful long time for a board this small, but yeah, it wasn't quite fully developed, so there are areas that still have like thin resist on it compared to others. But it will etch. We'll just take its sweet time about it. Now one thing I want to just mention here quickly whilst I'm waiting is on the schematic R4 is here and R3 is here. However, on the overlay R4 is here and R3 is there. They're actually inversed. R4 should be over here and R3 should be there. So it's actually back to front on the overlay, but it's still wired electrically correctly. It just means we've got to be careful which values to use. So I am planning on releasing the PCB file, so before I do that I might actually just correct that mistake so it matches this schematic at least. Okay, it's ready to assemble. It's all been etched, drilled, protected and whatnot. We are now ready for some testing. Alright, so the first thing I'm going to test is open loop gain, and the first one we're going to concentrate on is the non-inverting one. So as the name suggests, the input signal will be in phase with the output. Now we've got a resistor as an input resistor and a resistive load resistor. So in my case I'm using 1K over here and 22K over here. And just the negative terminal, the negative input terminal is grounded, and this is our signal generator in series with that 1K resistor. Pretty simple. So I've got the circuit board just sort of like hovering in mid-air above this breadboard here with wires coming off, and I've also got an NE5532 op amp over here, and it's wired the same way that this one is wired in the circuit, across the positive rail, negative rail. The 1K input resistor and the 22K resistor going to ground from the output. Pin 2 in this case going to ground. Input on pin 3 and etc. First, however, from memory, this is operating in class A. That means the output should be at half the supply voltage. So if you're going to use it as an audio amplifier, you've got to remember to put a blocking capacitor on the output terminal before the next stage, or you will be passing DC to it. So for all these tests I'm going to use plus minus 15 volt as the supply rails, and I'm going to use my handy dandy newly constructed regulated supply for that. I've got the multimeter connected across the output resistor of the Discreet Op Amp, just so we can see if indeed we have half the supply voltage at the output terminal. Turn it on. And indeed we do. We've got 14.9, which is exactly what I said. So as I said, that little module is operating at class A, or in class A mode. So you must put a blocking capacitor at its output if you intend to use this as an audio amplifier. unless you want to amplify DC, of course. Alright, got everything set up, got the power supply ready to go, got the DDS at 1 volt, 1 kilohertz, and I'm going to do all tests for everything at those settings. I'm not going to change it. I'm currently connected with 2 oscilloscope probes, one measuring the input, which is the yellow one, and the green one's measuring the output of the circuit of the discrete side. And as we can see, we've got an output at 1 volt roughly, peak to peak, coming out from the input. So if I now turn the power supply on, well, we're supposed to be seeing an output voltage on the green one, but currently we are not, which is kind of depressing. Right, I fixed the issue. The input from the DDS does not like being connected directly to the op amp's input. It needs to go through an input capacitor. Duh. And testing on the normal op amp, the NE5532, we indeed have a rather clipped but an open loop gain output, and we're pushing 29.8 volt. Alright, now I've moved over to the Discreet op amp, and it's configured the same way as the NE5532 is, which is currently turned off. So I turn the supply back on. Boom, there we go, we've got an output. And we're getting a little bit better, 31.37 volt peak to peak out. Albeit that the output signal looks like crap, but now would be the time to then change the configuration around to inverting, and there's our configuration down there for that. We just have Rn going into the negative input, the positive is now grounded, and there's no load on the output. So we remove that 22k, leave the 1k where it is, and see what we get. Okay, that's swapped around now, turn it on. Yes, we do have an output, albeit it looks like shit, but we've got an open loop gain of 31.37 volts. Okay, it's the NE5532's turn with it in inverting open loop gain. And currently I don't have an input signal because I haven't actually moved the input over to where it needs to be, which is over there. Now we have an input signal. Now I'll turn it on, and the output looks a little bit more symmetrical compared to the discrete version, but we're looking at 29.8 volt peak to peak in inverting open loop. Right, so now we want to look at closed loop gain on both op amps, and in both configurations, both inverting and non-inverting. So first we're going to look at non-inverting, which is our standard configuration. Input comes over here. We have an input resistor, which is going to be our impedance resistor plus ground reference resistor for the positive input. That's going to be set to 22k. There's no output ground reference resistor anymore, that's gone. And I'm going to be doing both tests with a gain of 23, so that's going to be 22k here and 1k for that resistor that goes to ground there. So as we can see, we've got a nice sinusoidal waveform out, and we're getting roughly 25 volt peak to peak, which is, if you do the math, 1 volt in should equal 23 out. So if I put that in times 1, it's going to clip because the oscilloscope is limited to 10 volt. So anyway, we have 25 thereabouts volt peak to peak output. Okay, so now it's the NE5532 op amp's turn. Currently the power supply is off, so I turn it on. We've actually got a little bit less than the other one. We've got 23.5 volt peak to peak. So far, all these tests are looking pretty good. So now it's time to look at the inverting gain of 23. So in order to get a gain of 23, it's RF divided by Rin. So if we have 1k here as an input resistor and 22k as a feedback resistor, we're going to get a gain of 22. So it's not quite going to be 23, but for purposes of testing, it's close enough. I accidentally bumped that little bugger with the tripod leg. Oh, there he goes. And I kind of scared him and scared me at the same time. Where are you up to? Where are you up to? This is not a very good tripod for panning. It's pretty crap. Okay, so I got the Discreet Op Amp connected in the inverting direction as a gain of 22. Alright, so I'm ready to turn the power on. And we do indeed have an output. And we're looking at 21.9, so that's the gain of 22. So effectively it works. Now for the op amp, or the NE552's turn. I hope you guys are appreciating this, because this does actually take quite a fair bit of time to change wires around and edit it so it's concise. Okay, so we're swapped over and that's configured now as inverting to the other op amp, to the normal op amp. Indeed, we have an output. And we're pushing 21.9 as well. So again, do the math, it's a gain of 22. Well, so far that's all fine and dandy, but what about using the op amps as a voltage follower or a one-to-one buffer with unity gain? So first we're going to look at the non-inverting version, which is we have an input resistor here, which is going to be the 22k to ground. That's just a ground reference input resistor. The negative's directly connected to the output. Now this is a good test because it could end up destroying the Discreet Op Amp altogether. And then we have the output formed between the two. So it's just basically one component, no feedback, anything. So this is a one-to-one buffer or a non-inverting voltage follower. So if there's 1 volt here, we should have 1 volt there. Penis. Okay, the Discreet Op Amp is now hooked up as a voltage follower, and we'll see if this survives. Okay, so currently the power is off. Turn it on. We do have an output. We can't see it. But if we put the oscilloscope back into ×1 mode, we do actually have an output of 1.4 volts. So it is actually operating as a voltage follower, albeit noisy as crap. But I'm on 5 volts per division, so if I drop that down to 1 volt, yeah, it's pretty noisy. Could be because it's oscillating. But anyway, we know that that does work. Right, so the NE552 is hooked up as a voltage follower, non-inverting. Turn the power on. And as we can see, it is working as a voltage follower. However, it is not anywhere near as noisy as the Discreet version. I reckon the Discreet version is oscillating. Now it's the inverting voltage follower, or buffer if you like, turn here. So we're going to have 2 resistors, an input resistor and a feedback resistor. I'll make them the same because they have to be the same to have one-to-one output. So 22k, 22k, that gives us a gain of 1, or unity. And we'll try both configurations, first being the Discreet. Okay, the Discreet Op Amp is hooked up in one-to-one or unity or voltage follower mode, in inverting mode. All I do now is just look at the output on the scope. And currently we're not going to have fuck all because everything's going the wrong way. So, alright, well even with the power off, we can see we've got about 878 odd millivolts coming out. But that's only because it's going through the resistor network. So if I turn it on, we actually get an amplified signal instead. But notice how it is actually inverted compared to the upper one, which is measuring the input. That is, if the screensaver wouldn't activate. So if I turn it off, and it disappears, now it starts to come back because, well, there's nothing going through the circuit, it's just going through the resistors, and it's gone the same phase. So that's just how unity gain buffers work. But it does work fine in unity gain, voltage follower, non-inverting. So I got the NE552 hooked up as a one-to-one unity gain buffer or voltage follower in the inverting mode. I don't even know why I'm bothering to test the NE552. We know it's going to work. And looking at the output with the thing off, again we've got the same effects as the Discreet version. We've got an output going through the resistor network, the 222Ks there, back to the output. in phase with the input, and we're pushing about 909 millivolt thereabouts. So if I turn the power on, boop, it corrects itself. Now it's 180 degrees out of phase with the input. And we're about 1 volt. So yes, we know an op amp works as a unity gain buffer. So just to recap, I have been keeping a table of my results so far. So first let's look at our open loop gain. The discrete version, non-inverting, was 3.17 volt peak to peak. The NE5532 in non-inverting was 29.8 volt peak to peak. In inverting mode, 31.37 volt peak to peak. And the NE5532, that was the discrete, the NE5532 was 29.8 volt peak to peak. You can see these figures are the same. These two are slightly different. For the closed loop gain equals 23 roughly. In the inverting mode it's 22, but splitting hairs. The discrete version fared non-inverting at 25 volt peak to peak. The NE5532 fared at non-inverting 23.5 volt peak to peak. And inverting, the discrete was 21.9 volt peak to peak, a little lower, but remember we were operating at a gain of 22 there, not 23. And the NE5532 was inverting 21.9 volt, and we can see that both inverting configurations on both types of op amp are the same. So can the discrete operational amplifier be used as a voltage follower? In non-inverting mode, it starts showing signs of oscillating. The NE5532 in non-inverting mode, yes of course. The discrete in inverting mode, yes. And the NE5532 in inverting mode, of course yes. So far the tests have proved that the thing does actually work as an op amp and can be used as an op amp, and amplifies just fine. But I can hear you all screaming at the screen right now, Astro! Astro! That's all you're screaming at the screen right now. No, I can hear you asking the question, well, what about its frequency response? Of the discrete version, that is. Well, let's have a look. Alright, so I'm going to be using the inverting voltage follower mode. It's simple enough. For all intents and purposes, it doesn't really matter. So we're going to sweep mode, and we can look at both traces and see if they change any differently between each other. So let's go. No, not really. Not sure what frequency we're at now, but we can see it's remaining pretty flat. So yes, its frequency response is fine as far as I'm concerned. So we'll go back to continuous mode. And yeah, we'll call it there. So I think I'm going to leave this video here. I know I did say that I was going to hook the discrete module up as a preamplifier and put it out into a power amplifier and do a sound test, but I don't really see the point. Considering we've already seen the overall frequency response, it's pretty good. So I would go on a limb and say that it's going to work fine as a preamplifier. We saw what it looked like with a clean continuous sine wave going through it at a gain of 23. Use your own discretion. So anyway, I've tested out my new 1 amp plus minus 15 volt regulated power supply for the first time. That's the exact purpose I built this for, and it's proven to work very well. So anyway, this is the Astro 30 saying thank you for watching, and if you enjoyed this video, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying Happy New Year for 2019.